Okay, for this introduction on tension, we are going to look at the tension in the rope. Tension is just the force inside the rope causing it to move. The thing you have to know about tension is tension pulls in both directions. And when you look at the tension of a rope, for example, here, the tension of the rope here, 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 it's all going to be constant no matter where you look at the rope. So usually when we solve tension problems, it requires us to break the diagram or the picture we got so we can try to calculate the force inside. Because in order to see inside the tension of the rope, we have to break it up. So if we look at this example for here, we have a 30-kilogram box being held up by a rope. And I want to find the tension in the rope. So in order to find the tension in the rope, we start off by separating it into two pieces. So in one piece we have the box, and this box has the following forces acting on it. It has the force of gravity pushing it down, and it has the tension of the rope, which is the main thing keeping it from falling, pushing it up. Okay, now we look at the other part that we didn't so here we have the ceiling, and we have a force coming down. That's the tension of the rope pulling down, which is the same. These and this is the same. It's just pulling in opposite direction. And we have the force of the ceiling, just call it force of ceiling, C, pushing it up. So we try to calculate. So this is our free body diagram cut. So if we start looking at the first one, because it's not moving, the net force in the y direction is going to equal 0. That means, because it's not moving, that the tension has to be minus the force of gravity, because force of gravity is pointing down, has to equal 0. And the force of gravity is just 30 times 9.81, which gives us 294.3 newtons. That's our force of gravity. So when we plug it in, we have our net force in the y, which is equal to 0, is equal to the tension minus the 294.3 newtons, which means our tension is equal to 294.3 newtons. That's our tension. Which means that this tension here also has to equal 294.3 newtons pushing downwards. So now we can try, if we're looking, for example, for the force of the ceiling, we can actually calculate that. Because neither of them is moving, we'll say the net force in the y is 0, which means that our force of the ceiling minus the 294.3 newtons has to equal 0. So that means the force of the ceiling has to be 294.3 newtons. Then we have our answers. We have the tension in the rope and the ceiling. So this is the basic tension. But again, this was really the question we were looking for. We were really concerned with what the tension of the rope was. So that's the basic one. In the next one, we'll start doing things and get a little more complicated.